Alright, so for number one, I know they're asking you to use a graphing calculator to make a table, but we're just going to use transformations. So right here, b is -1, okay, because that's a coefficient of x. So we multiply the x by -1, so we get 0, 1, and -1, 10. Okay, so we sketch it now. Okay, the horizontal, remember exponentials have horizontal asymptotes. Since k is 0, the horizontal asymptote stays here at the x-axis. So the horizontal asymptote is y equals 0. We plot the points 0, 1, so about here, and -1, 10, about here, and connect them like that. So the y-intercept, intercept is 0, 1. It has no x-intercept because it just gets closer and closer to the x-axis, but it never actually touches it. Okay, so we identified the asymptotes and any intercepts. Alright, so number 3, the negative here is the a value, -a, and then this is your k value. Okay, sometimes they write it here, sometimes they write it over here. So it's still k. So that's why the y's are changed like this, -y plus 1. Over here, this is b. So this one, remember, does the reciprocal of what that says. So if this is 2, it's going to be 1/2. So it has a horizontal stretch or a horizontal compression by a factor of 1/2. So now we're going to transform the points. So 1/2 times 0 is 0. -1 plus 1 is 0. And then 1/2 times 1 is 1/2. And negative e plus 1 is -1.7. Because it's negative 2.7 plus 1. So now we're going to graph this. So the horizontal asymptote, because k is +1, horizontal asymptote went up here to y equals 1. And then we got 0, 0. And 1/2 -1.7, so that's about here. So you connect the points, and there's your exponential function. Intercepts, it has the intercept. You could call it the x-intercept, the y-intercept, but it's at 0, 0. Number 5, we're evaluating the expression. So remember, this 2 right here becomes a coefficient of the log. So it's 2 times 4.6 times natural log of e. Okay, so natural log of e, remember, is 1. So this part right here is 1. So 4.6 times 2 is 9.2. Okay, so now we're switching over to logarithmic equations, and they want you to graph it, find the domain, vertical asymptote, x-intercept of it, and then we're going to graph it. So first off, this negative here is -a, so it's going to affect the y right there. And then this is k, -6, so that's going to affect the y again. So you have 1, -6, and 10, -7. Now remember, it's 10, 1 because this is the base right here. So now we're going to sketch it. Alright, so logarithmic equations have vertical asymptotes determined by h. H in this case is 0, so we have a vertical asymptote right here. X equals 0, so vertical asymptote, x equals 0. We're going to plot the points 1, -6, and 10, -7. So it's about here. Okay, so notice 10, -7 is a little lower than 1, -6, so it goes, I know it's kind of hard to draw here, but it goes like this. Okay? The domain is all x such that x is greater than 0. Okay? The intercept, we want to know where it crosses the x-axis because it's not going to cross the y-axis. So we know that on the x-axis the y is 0, so we're going to make f of x equals 0 and then solve this equation right here. So we add 6 to both sides, and then the negative moves over, divide by -1, and then convert it to a exponential. So base is 10, the exponent is -6 equals x. So this is the exact value of the x-intercept. So we'll say x-intercept is 10 to the -6, comma 0. Number 9, the parameter, well, first off, the reference points are 1, 0, and base 1. Base in this case is e. H is 6, positive 6. Remember, you take the opposite sign of what it says here. So 6, and then k is positive 1. So 6 plus 1 is 7. 0 plus 1 is 1. E plus 6 is 2.7, so that's 8.7 when we round it to the nearest tenth, and then 1 plus 1 is 2. So now we're going to graph. Alright, so first thing we're going to draw is the vertical asymptote. Because h is 6, it goes right here at x equals 6. So the vertical asymptote is x equals 6, and then we have 7, 1, and 8.72, so that's approximately right here. Connect the points, oops, I erased it, sorry. Connect the points, it goes something like that. The domain is all x such that x is greater than 6. And for the x-intercept, remember we solved for x, f of x is 0. So we subtract 1. So -1 equals natural log of x minus 6. And now I'm going to convert it to exponential, so the base is e. The exponent is -1, and it equals x minus 6. So now I'm going to add 6. So what this gives me is that the x-intercept is 6 plus e to the -1, 0. We plug it into a calculator, and it's 6.36, well, 37, or 6.4, and that's where this point would be. Alright, so number 11, they want you to evaluate this, and because our calculator does not have a base of 2/5, we have to use a change of base theorem. You could either do natural log of 1.3 over natural log of 2/5. I'm going to write it in as 0.4, because 2/5 is 0.4 as a decimal. You could also plug it in as log 1.3 over log 0.4. Now remember, do not mix up the natural log and the log. It's either both natural log or both common log. Put it in a calculator. Oops, looks kind of weird. Put in a calculator, and it's approximately -0.286 because they want you to round it to 3 decimal places. For number 13, we're expanding the log. So this, I see here a product. So I'm going to separate that as the sum of the logs with a base 2. So log base 2 of 3 plus log base 2 of 8 to the 4th. Now that 4 is going to become the coefficient of that log. So you get log base 2 of 3 plus 4 log base 2 of a. And that's as much as we can do. Alright, 15, we're expanding this. So again, I see the log of a quotient, which will become the difference of the logs. So natural log of x, square root of x plus 1, minus natural log of 2 e to the 4th. Now I see two products, right? I see a product right here, the log of a product, and then there's a log of a product right here. So I'm going to separate that as the sum of two logs. So natural log of x plus natural log of, and I'm going to write it as x plus 1 to the 1/2. Now, this negative right here affects everything after it, right? So when I separate the logs, I'm going to put parentheses. So natural log of 2 plus natural log of e to the 4th. Okay? Now, the exponents, the 4 and the 1/2, become coefficients of their respective logs. Okay? So it's, and I'm going to distribute the negative also as I do this last line. So this is going to be natural log of x plus 1/2 natural log of x plus 1 minus natural log of 2, and the negative is going to be distributed here, so minus, and then the 4 comes down, 4 natural log of e. So this is the expanded form of number 15. Alright, so for 17, the coefficients, now we're doing the opposite. We're condensing the logs, so that means that when we finish, we're going to have a single log. So the 4's become coefficients, so you get natural log of x to the 4th minus natural log of y to the 4th. So now I have the difference of two logs that have the same base, right, base e. So I'm going to convert those to the quotient, the log of the quotient. So natural log of x to the 4th over y to the 4th, like that. And you can leave it like that, or just write natural log of x over y to the 4th. Alright, so number 19, we can write 81 with base 3. So 81 is 3 to the 4th, so then that means that x equals 4. Number 21 is in logarithmic form. We could change it to exponential form. The base is 7, the exponent is 6, and that equals x. So, so x equals 117,649. So I'm going to multiply both sides by this denominator. So I'm going to multiply by this denominator. So when I do that, I get, on the left side it cancels. So we're left with that. On the right side it's 5 times 8 plus e to the 4x. So I can divide by 5, especially because I see that 1025 is divisible by 5. So that's going to give me 205 equals 8 plus e to the 4x. I'm going to subtract 8. So that gives me, it's going to give me what? 197 equals e to the 4x. I'm going to change it to log form because right now it's an exponential. So natural log of 197 equals 4x. I'm going to divide by 4. And so this would be the exact value. When you plug it into the calculator, you get x is approximately 1.321. Alright, so because they have the same base 10, I'm going to combine them as a single log. So the difference of the logs is the log of the quotient. So this becomes log of x over 8 minus 5x equals 2. Now I'm going to convert it to exponential. So base is 10 squared equals x over 8 minus 5x. So now I have 100. I'm going to multiply both sides by 8 minus 5x. So I've got 100 times 8 minus 5x. On the right side, the denominator cancels. So it's 800 minus 500x equals x. I'm going to add 500x. So I've got 1x already, so it's 501. Divide by 501. Okay, so that would be the exact value. And here's the approximate value after you plug it into the calculator. So we're using the formula for half-life. And so they want to know if after 15 years how much of this actinium would be left if its half-life is 22 years. Plug this into the calculator and you get 0.623. So you would have, this is the original amount, after 15 years you would have 62.3% of it left.